Hello, good morning, students. Today we are going to understand the sodium hydroxide, student. Okay, so we will study the preparation of sodium hydroxide. We know that is sodium hydroxide formula is NaOH, and this at the same time we know that is sodium hydroxide is also known as caustic soda. That is also known as caustic soda. Okay. Now there are certain method of preparation are there. We will go one by one. So there are 5 method of preparation is there, student. The first method is by causticizing process, Lowing process, Nelson cells process, caustic Kellner process, that is mercury cathode process, Kellner solvay cells. So there are following 5 processes are there, student. Causticizing process, Lowing process, Nelson process, caustic Kellner process, that is mercury cathode process, Kellner solvay cell. So the first one is that is causticizing process. Okay, that is also known as Gauss's process. Here sodium carbonate is treated with the milk of lime, calcium hydroxide. So what it will give, student, it will directly take this hydroxide and O. So 2 mole of sodium hydroxide will form and calcium carbonate will be precipitate out. So that is what is the Gauss's process or causticizing process, where sodium carbonate is treated with calcium hydroxide. It will give, that is sodium hydroxide. And the second method is there, lowing process means that is sodium carbonate is treated with Fe2O3, okay, Fe2 ferric oxide. So Fe2O3, when it is treated, student, it will firstly form, that is sodium ferrite, NaFeO2 plus carbon dioxide. Okay, this sodium ferrite NaFeO2 react with hot water, it will give sodium hydroxide and insoluble Fe2O3. So this is what is, student, that is the sodium hydroxide is getting prepared by lowing process. Next one is there, student, Nelson cell process. In that also we prepared, that is the sodium hydroxide in the Nelson cell. So in Nelson cell, aqueous sodium chloride solution is electrolyzed using perforated steel as cathode and graphite as anode. So steel is used as a cathode, student, and graphite as a anode. That keep in mind, graphite is using as a anode and steel is used as a cathode. So electrolyte we are using, aqueous NaOH, cathode perforated steel is there, anode, reaction at anode. So NaCl, it is decompose Na plus and Cl minus, H2O decompose H plus and OH minus. So cathode reduction and anode oxidation. So 2H plus 2 electron H2, 2 chlorine Cl2, 2 electron. Now this, student, 2H plus and what will do, and from the 2H plus of this, okay, so H plus not required for this reaction. We required here is, student, this Na and OH. This will be what is, this is getting discharge, student. H2 is discharge, Cl discharge. What is left? NaOH. So Na plus OH minus, this will give, that is our required product. Okay, here next one it is Kellner cell. In outer compartment, that is cathode is mercury, graphite is anode. Electrolyte we are using, that is brine solution, NaCl. So NaCl you give, electrolyte, it will give 2 Na and 2 Cl minus. At anode, 2 Cl minus will give Cl2. At induced cathode, Hg plus 2 Na plus 2 electron, Na2 Hg. So middle apartment, iron rod, mercury and electrolyte we are using, that is again NaOH. So at induced anode oxidation, NaHg 2 electron, it will give Na plus Hg. At cathode it will give 2 Na plus H2O plus 2 electron, that is NaOH plus H2. The amalgam is treated with water to get NaOH. So 2 Na plus Hd plus water, 2 NaOH plus Hg plus water. This is our required product, student. So what you need to do, student, you need to write down the equation and then you need to practice. Then only there will be the little helpful Okay, so thank you so much for watching, dear students.